All right, hey people again. We're gonna start off this time before we get to the next two exponent rules, actually three, with a joke. So, why was the broom late for school? Because he overswept. Ah, ah, ah. All right, so the next two major exponent property rules we just talked about multiplication. The next two major ones are the division with our powers, and then our negative exponent rule as well. So we're going to start here with our division of powers. So very similar with your multiplication rules. So with a power times a power, remember we had a power times a power with the same base. We added the exponents. It's almost like the complete opposite. Multiplication and division are inverses. Well, guess what? This was addition. So division, we're actually going to think subtraction. So if you have a power divided by another power with the same base, we actually just subtract our exponents or powers. So there's your algebra. Here's what it's going to look like with a number. So 2 to the 7th divided by 2 to the 5th. That means there's 7 2's up top here. There's 5 2's down here. We would cross out until you have some left. Or you can just think, hey, that's 7 minus 5. This would be 2 squared or 4. So with a power divided by a power with the same base, you just subtract your exponents. A little trouble here writing. All right, I'll show you one more example with this with some variables. So we have x to the 8th divided by x to the negative 3rd. So you'd say, hey, that's x to the 8th divided by x to the negative 3rd. You're going to say 8 minus negative 3. So that's going to become plus positive. So that will be actually x to the 11th power. So that's your division of power rules. So if we flip here a couple pages, go through some examples. So 5 to the 6th divided by 5 squared, 6 minus 2, that would be 5 to the 4th power. Again, we're not worried about actually what this equals. I just want your base to a power here. So give you another example with certain negatives. So m to the negative 3rd divided by m to the negative 5th. You want to make sure you subtract that correctly. So it's negative 3 minus negative 5 plus positive. And that gives you m to the 2nd power. So as you can see, there's other examples. It's always with the same base. So when you're dividing a power with the same base, you subtract your exponents. So just to show you a little example as adding our other rules into it. So we have this power raised to a power in this case. So we have this a times b to the 3rd divided by a to the 5th times b, all raised to the negative 2nd power. What we would do here is we would have our power raised to a power. So we'd actually take that to every single part. Okay. Or you could actually subtract first since we have the same base. So this would be a to the 1st because there's no power written on it. So 1 minus 5, that would give me a to the negative 4th. And then 3 minus your 1, that's going to give me b to the 2nd. And then we would raise all of those to the negative 2nd power. So it's kind of combining our rules here together. So negative 2 times negative 4 is going to give me a to the 8th. And negative 2 times 2 is going to give me b to the negative 2nd. All right, now we're not going to normally leave it like this, but you'll see actually in this next rule how we're going to change this negative 2 to actually a to the 8th over b to the 2nd. So that's where we're going here. So we're going to go back. That's your division of power rules. And we're going to talk about our zero and actually negative exponent rules. So zero and negative powers. All right, so your zero power rule, this one's really simple. Anything to the zero power equals 1 except 0. Okay, so anything to the 0 power always equals 1 except for 0 to the 0 power. That actually would be like undefined because it's like saying 0 divided by 0. So if I show you an example here, 136 to the 0 power, that equals 1. And essentially how this works is if we had, let's say, 2 to the third power divided by 2 to the third power, okay? These are the exact same number. This is 8 divided by 8, and 8 divided by 8 equals 1. So the idea that you come back to your division of powers rule is, hey, this is 2 to the third divided by 2 to the third. All right, we'll subtract. 3 minus 3 would give me 2 to the 0, and 2 to the 0 equals 1. So it's kind of just you proving that whole, hey, this is a number divided by itself, it equals 1. All right, so that's your 0 power rule. And then we have our negative, and this is a big one. So moving forward here, you don't want any negative exponents. You always want to change them to a positive power. So the idea that a negative exponent is not a negative number. A negative exponent actually means a number less than 1, a fraction, a decimal in that sense. So if we said, this would be my example, x to the negative a power, okay, that actually represents a fraction to that power. So a negative exponent does not mean a negative number. It just means a number that's in between 0 and 1. It's a number less than 1. So it's a fraction, it's a decimal. So here would be an example. You got 2 to the negative third power. That actually means 1 over 2 to the third power, or you could say, hey, that is actually 1 over 8. So if you think about it, all we're doing here is it's actually called the positive power reciprocal. So when we think negative exponent, you want to think reciprocal and positive power. So here would be another example. So let's say we had x to the negative fifth power. Well, you're going to think reciprocal, so that would be x to the negative fifth over 1. So we're going to flip it, and then you're going to take the positive power. So 1 over x to the fifth. So reciprocal and your positive power here with any negative exponent. Now, one other example, well, what happens if you have a negative exponent in the denominator? So let's say like 6 to the negative 7th power. Well, it's the same idea. You want to think reciprocal. So you're going to flip this. You'd have, hey, it would be actually 6 to the negative 7th over 1. But again, we're going to go to that positive power. So this is going to be flipped. And it's just going to be actually 6 to the 7th over 1, which just is 6 to the 7th. So essentially, whenever you have this negative power, you want to flip it. And if it was in the numerator, it goes down to the denominator. If it was in the denominator, it goes up into the numerator. And then you think positive power. So we like to move actually these negative exponents to make them positive. So take a look at some examples of this. So again, anything to the 0 power is always going to be 1. So 13 to the 0 power is 1. So 5 to the negative third. Think reciprocal. Then you're going to flip it. It's going to go down here in the denominator, and you're going to have your positive power. So 1 over 5 to the third. A negative exponent is a fraction, a number less than 1. Okay, you can think, hey, if I went from 13 to 0 as 1, well, then 13 to the negative first power is going to be less than 1. And that's where it becomes our fraction. So here would be an example with your division power rules. So you have 3 to the first divided by 3 to the negative fourth. You're going to subtract. So 1 minus -4, that'd actually be 3 to the 5th power. Or you could think, hey, this is my negative exponent. I'm going to take that up to the top. So you'd have actually 3 to the 1st times 3 to the 4th. And then you have a power times a power with the same base we add together. And you get to this 3 to the 5th power. So essentially is if whenever you have this negative power, you want to be thinking moving it. You want to think flip, reciprocal. So in this case, it would actually be 2 times 4, which is just 8. All right, so when we have this negative exponent, we want to think positive power reciprocal. That flip, that moving of where it is in that situation. So there are some examples with your negative exponents. Yeah.